Hello viewers, in today's lesson we will be discussing about differential calculus, and as we all know that calculus is divided into two aspects, and the first aspect is the differential calculus and the second aspect is the integral calculus, which we will be discussing in the subsequent lessons. So without further ado, let's jump into what we have in this lesson. And in this lesson we will be discussing about the first principle of differential calculus. So this particular function, we want to find the first derivative in this particular function using the first principle. And the first derivative of this function y, which is also giving us f of x, the first derivative is always denoted as the y dx, which is also f prime of x. This is giving us f of x plus delta x minus f of x all over delta x, setting the limit of delta x to 0. In this particular function, f of x equals to 2x cubed, then f of x plus delta x will be giving us 2x plus delta x all raised to power 3. That is, we'll be expanding this particular function to the power of 3. Now, let's expand the function to the power of 3. That is, we'll expand it to the power of 2, and we also multiply it by x plus delta x. And that can be written as 2x plus delta x all squared multiplied by x plus delta x. And this becomes 2 x squared plus 2x delta x plus delta x squared, then multiplied by x plus delta x. Then we expand it once again, and that gives us 2 multiplying x squared with x, and that gives us x cubed, x squared delta x, and that gives us plus x squared delta x. Likewise, the second term, which gives us plus 2x squared delta x plus 2x delta x squared. Likewise, the last term, which gives us plus x delta x squared plus delta x cube. Close the bracket, and that gives us, opening the bracket with 2, that gives us 2x cubed plus 2x squared delta x plus 4x squared delta x plus 4x delta x squared plus 2x delta x squared plus 2 delta x cubed. Then the y dx It's giving us the limit of delta x to 0 f of x plus delta x minus f of x, and this is f of x plus delta x. Then the expression becomes 2s cubed plus this and this can sum together 6s squared delta x, and this with this can sum together plus 6s delta s squared plus 2 delta x cube. These are together. Now divide the x, which is f of x plus delta x minus f of x. Now it gives us 2s cubed plus 6s squared delta x plus 6x delta s squared plus 2 delta s cubed minus f of x, which is our 2s cubed, all over delta x. Now 2s cubed cancels out 2s cubed. Then you are left with y dx, which is equals to 6s squared delta x plus 6x delta x squared plus 2 delta x cube all over delta x, setting the limit of delta x to 0. The next thing is to what? To distribute the denominator to each times of the numerator. Then we can write our di dx as 6s squared delta x all over delta x plus 6x delta s squared over delta x plus 2 delta s cube over delta x. Then delta x can cancel delta x. Delta x will cancel one of these. Then but we'll be left with delta x, and delta x will also cancel one of these. We'll be left with delta x squared. Then setting the limit of delta x to 0, then automatically our dy dx will be as 6s squared plus 6x delta x. Remember, we are left with one delta x here, plus 2 delta x squared, setting the limit of delta x to 0. Now the y dx is finally giving us, substitute 0 in any way you found delta x, and that is what? 6s squared plus 6x multiplied by 0 plus 2 multiplied by 0 squared. Automatically the y dx gives us, this becomes 0, this becomes 0. Y dx gives us 6s squared finally, and that's the final answer to that. Then we can try to solve one more example on the first principle. Solving one more example on the first principle, could have f of x to be equal to, let's say, 4s squared plus x. 4s squared plus x. And we all know that f prime of x, which is our dy dx, is giving us the limit of delta x to 0 of f of x plus delta x minus f of x all over delta x. And in this case, our f of x plus delta x is giving us 4 x plus delta x squared plus x plus delta x minus 4x squared plus x all over delta x. Then we have to expand this. Then we also have to simplify the expression. And that automatically gives us 4 s squared plus 2x delta x plus delta s squared plus delta s squared plus this, no, plus x plus delta x, everything minus 4x squared plus x all over delta x. Then we could expand this bracket with 4. Then we simplify it together with this. Remember? And this gives us 4s squared plus 8x delta x plus 4 delta x squared plus x plus delta x minus, we can also simplify this to become minus 4s squared minus x, since we use this minus to open the bracket. Everything delta x. We can now simplify the expression. Then to simplify the expression, minus 4x squared can cancel out 4x squared, neglecting the bracket. So automatically, an x can cancel out x. We have 4x squared to cancel out minus 4x squared. And also, x can cancel out x. And we are left with 8x delta x plus 4 delta x squared plus delta x all over delta x. And the next thing is to distribute delta x to each terms of the numerator, and that becomes 8x delta x over delta x plus 4 delta x squared all over delta x plus delta x over delta x. So automatically f prime of x gives us the limit. Don't forget, we have to set the limit delta x to 0, and as you can see, delta x here cancels out delta x, and delta x here cancels out one of it. We are left with delta x, and this cancels out this to become 1, and automatically here we have 8x plus 4 delta x plus 1. Then setting delta x to 0, anywhere you have delta x, you put 0, then automatically f prime of x equals 8x plus 4, 0 plus 1, then 4 times 0 gives us 0, and automatically this gives us 8x plus 1, and that gives us our final answer. So we have been able to differentiate a particular function. We've been able to find the first derivative of a function f of x using the first principle. In the subsequent videos, we will be talking more about finding the first derivative of a function using the first principle, and we'll also be discussing about the power rule of differentiation, which is a much shorter method of finding the first derivative of a particular function. So then do well to subscribe to my YouTube channel for more awesome videos on maths, engineering, and science problems. Thank you.